Hello, and welcome to this second session on waves. If you didn't watch the first session, ask your teacher and they can share the address on Streams. You should be listening to this directly from Streams rather than the teacher sharing their screen. Today we're going to have a look at light waves and the electromagnetic spectrum. Take a look at this picture. There's a person standing next to a screen and there's a lamp that's shining on them. You can see that the person has a shadow projected onto the screen. The person is saying, my shadow is biggest when I'm close to the screen. And they're surrounded by three people who are trying to explain it. Let's call the first person, person A. They say that your shadow is biggest when you're closest to the lamp. Person B, in the bottom left, says that standing close to the lamp makes your shadow clearer. Whereas person C, in the bottom right, says that the shadow is the same no matter where you stand. These are three interesting statements. I wonder if you agree with them or not. What I'd like you to do is have a think about those statements, and then for persons A, B and C, write down what kind of argument would they use to justify their opinion. Then write down what you thought was the correct answer. Do an experiment, a very simple one, just at home, to work out what the right answer is, and then write down what you found out. So what I'd like you to do is pause the video, answer these questions, and then report them back to your teacher. Pause the video now. Here's another situation. We've got two trees, both casting a shadow, and the shadows are overlapping. And we've got three more opinions. A is saying the shadow is twice as dark where they overlap. B is saying the shadow is a bit darker, but not quite twice as dark. And C is saying the shadow is just the same where they overlap. Again, write down what they would use to support their view. Then decide what you think. Do an experiment to see if you're right. And then if needed, change your answer. Write these things down and pass them to your teacher. Pause the video now to do this task. Did you know that there's sounds that we can't hear and colours that we can't see? That sounds a little weird, doesn't it? But have a listen to this. Can you hear it? I can't, and it'd be interesting to know if your teacher can hear it either. This was called the mosquito ringtone. Originally, it was a very high-pitched noise that was invented to be used in shopping centres, like the Glades, in order to drive away teenagers. The idea was the sound was too high-pitched for adults to listen to, so they wouldn't be bothered by it, but teenagers would. The teenagers were quite smart though. What they did is they took that sound and recorded it, and they used it as a ringtone. So they had a ringtone that they could hear, but adults couldn't. So that's a sound that adults can't hear, but teenagers can. What about colours? If you take a look at your TV remote control, at the end you'll see there's some little LEDs. And if I have a look at them and press the buttons, I can't see them light up. But if I point it at you using my webcam on my laptop, you'll see it lights up pretty clearly. So this is a colour that my webcam, and therefore you, can see, but if I look at it, it doesn't seem to be lighting up at all. There are even sounds that no human being can see. Usually the lowest pitch sounds that human beings can see, the ones which have the lowest frequency, are about 20 or so hertz, maybe 30 hertz. And the highest pitched are kind of 20,000 hertz, 20 kilohertz. Dogs, on the other hand, can hear much higher pitched sounds, ones that have a much higher frequency, say 40 or so kilohertz. So a vibration that's 40 kilohertz, 40,000 times a second, is going to be something that's vibrating really quickly and making a very high pitched noise. Things like dog whistles are special whistles that dogs can hear but human beings can't. So they'll typically have a frequency about 30 or so kilohertz, a frequency that's above the 20 kilohertz that human beings can hear, but within the dog's hearing range. Really high pitched sounds like these, or things that are higher than a human being can hear, are known as ultrasound. Some animals can see different color ranges to us as well. Pollinating insects like bees can sometimes see in UV, ultraviolet light, which are a really high frequency, far too high frequency light for us to see. And you can see here there's a flower on the left, which has just had its photograph taken using regular visible light, the light that we can see. But the one on the right has also been taken using UV, and you can see that there's an area there in the UV light that shows the bee exactly where the pollen is, so it can go in there and help to pollinate the flower. We can use infrared photography to take interesting pictures. The picture on the left has been taken using a regular camera with regular film in it. The picture on the right has been taken using a film with infrared film. You can see that it's much easier to pick out the river on the picture on the right than the picture on the left. So there are two colors that we can't see: infrared and ultraviolet. But if we can't see them, how do we know that they're there? Well, one experiment was conducted by a guy called William Herschel, and you can see a picture of him in the bottom left here. He's got sunlight from the outside from the sun, and he's cut a little hole in his wall or in the curtains, and that's shining through, and he's put it through a prism so it makes a rainbow. You can see the setup a bit better up there at the top of this slide. He's got a few different thermometers there. He's put one thermometer in the blue, one thermometer in the yellow, one thermometer in the red, and then he's also put another outside of the rainbow, just past the red. And what he did is he had a look at these thermometers because he's trying to work out if light can heat things up. And he put the one just outside as a control, just so he could compare that temperature with all the ones in the different colours. And what he found was that the red thermometer was the hottest of the colours. But then he had a look at the one that was outside of the rainbow, and he found that that had heated up even more. It was a much higher temperature than even the red. So he deduced that there must be something past the red that was heating things up, a colour of light that he couldn't see with his eyes, but was having an effect on the thermometer. This colour past the red he named infrared. So we've got our colours of visible light, the light that we can see. But let's add infrared onto there. So infrared is a colour of light. It's got a larger wavelength, a lower frequency, and let's stick it right next to visible light, the light that we can see, just after red. Herschel discovered infrared light. He used a prism to split sunlight into the spectrum of colours into the rainbow, He put a thermometer in each colour and saw that the colours were different. They had different temperatures. The red was the hottest of all the colours, but it was even hotter just past the red. So he called it infrared radiation. After that, a guy called Johann Ritter did a similar experiment. Again, he used the prism to split sunlight into the spectrum, into the rainbow. And then he put something called silver chloride, basically photographic paper in each colour. And he saw that it turned dark in different colours. It was quicker towards the violet end. And a bit like what Herschel did, he put some silver chloride just past the edge of the rainbow, just past the violet end. And he found that it went black even faster. So just like Herschel concluded, there must be a colour there that we couldn't see. That colour he named ultraviolet radiation. So let's add that ultraviolet to the other side of visible light. We've got infrared having a longer wavelength and ultraviolet having a shorter wavelength. All this talk of invisible radiation has made me think about some of the news stories that we've been reading recently, particularly about 5G phone masts. There are some people that believe conspiracy theories that 5G phone masts are causing coronavirus. The Guardian has reported that at least 20 mobile phone masts across the UK have been set on fire or vandalised. We know that a lot of these conspiracy theories aren't really based on very much fact. But people are genuinely concerned about mobile phone radiation, and if it's part of this invisible radiation that we talked about. And in fact it is. We have visible light, the light that we can see, and longer wavelengths are called infrared. Shorter wavelengths than visible light are called ultraviolet. But if we go to even shorter wavelengths than ultraviolet, we get X-rays and gamma rays. We'll talk more about these next week. If we look at longer wavelengths than infrared, we have microwaves, and even longer still are radio waves. 5G masts use a type of microwave radiation that all mobile phones use. These exam questions look at people's concerns to do with mobile phones. They're taken from past AQA science exams. Read through the exam questions, then complete them and submit the answers to your teacher. Pause the video now to read through the questions, and then you can submit the answers to your teachers.